31 is on coordinate geometry, and we're asked to find the point xy on the Euclidean plane where the curve y equal to 2x squared minus 2x plus 3 as 2 as gradients. What is gradient? Gradient is slope, and it is the first derivative of this particular function. Therefore, we put dy dx is equal to 4x minus 2. Since the gradient is 2, it implies that our dy dx is 2. We now have 2 is equal to 4x minus 2. In this case, 2 plus 2 is equal to 4x, and x is equal to 1. Since x is equal to 1, we proceed to obtain the value of y. Obtaining the value of y here, we have y equal to 2 into 1 squared minus 2 into 1 plus 3. This one will give us 2 minus 2 plus 3. This one will go, become 0, and y is equal to 3. It means that the value of x is equal to 1 and the corresponding value of y is equal to 3. Therefore, the points 1, 3 will form the coordinate xy on the Euclidean plane where the gradient of the curve y equal to 2x squared minus 2x plus 3 is equal to 2. So the correct option there is option A. Question number 32. Two perpendicular lines P and Q, PQ and QR, so to say, intersect at 1, minus 1. If the equation of PQ is x minus 2y plus 4 equal to 0, we are required to find the equation of the line QR. Equation of PQ, according to the question, is perpendicular to QR at 1, minus 1. What do we mean by perpendicularity of two lines? Two lines are perpendicular if they intersect and the resulting angle at the point of intersection is 90 degrees. Two lines are also perpendicular if the product of their respective gradients is minus 1. So we're given the gradient, the equation of PQ, which is x minus 2y plus 4 equal to 0. So we consider this equation and write it in the standard form. Mark you, the standard form is y equal to mx plus c. So we proceed to write this one in this particular form. Minus 2y is equal to minus x minus 4. Therefore, 2y is equal to x plus 4. Y is equal to 1 over 2x plus 2. The gradient of this particular line is 1 over 2 because MA implies the gradients. MA implies the gradients. Now, looking at this one, critically, you will understand that my n is equal to 1 over 2. If m is equal to 1 over 2 and the two lines are perpendicular, it means that the gradient of the second line, which is QR, can be represented as m2. And since for perpendicularity, the product of their gradient must be equal to minus 1, we now have 1 over 2 m2 equal to minus 1. m2 therefore is equal to minus 2. We now write the proposed equation for QR. The proposed equation will be given as y equal to m2x plus c. This one implies that y is equal to minus 2x plus c. The lines intersect at 1 and minus 1. It implies that we are going to substitute 1 for x, 1 for x, and minus 1 for y. This one is going to be minus 1 is equal to minus 2 into 1 plus c. This one will give us minus 1 equal to minus 2 plus c. Therefore, c is equal to 1. Hence, the equation of QR will be defined as y equal to minus 2x plus 1, which can be written as y plus 2x equal to 1, or y plus 2x equal to y plus 2x minus 1 equal to 0, or y equal to 1 minus 2x. So it doesn't matter any of the forms in which this particular equation is written. You understand that the equation that best describes the line of Q here is 2x plus y minus 1, because this one can be rearranged to form that particular option. We move to the next question. Question number 33. For what value of x is the tangent to the curve y equal to x squared minus 4x plus 3 parallel to the x-axis? As you are looking at the question, you're talking about a curve and you're talking about a tangent that is drawn to the curve. For what value of x will that particular tangent be parallel to the x-axis? We need to understand some basic facts here, that at the turning point, the first derivative of this function will be equal to 0. That is, at the point of tangency, in this particular context, our dy dx is equal to 0. Therefore, we write y equal to x squared minus 4x plus 3. Then, we proceed to differentiate as the y dx equal to 0. That is at the point of tangency. Then, the y dx of the given function is given as 2x minus 4. So this one will give us 0 equal to 2x minus 4. Therefore, we put our 2x equal to 4 and x equal to 2. So it is at x equal to 2 that the tangent to the curve will be parallel to x-axis, and this is the curve. The next question. Question number 34. You are required to find the area bounded by the curve y equal to 3x squared minus 2x plus 1. The ordinates being x equal to 1 and x equal to 3. And the x-axis, you want to find the area bounded by the curve y equal to 3x squared minus 2x plus 1 with the boundaries 1 to 3 and the x-axis. From here, since you want to find this area, we integrate the function, and we integrate the function y with respect to x. Therefore, we substitute and have 3x squared minus 2x plus 1 dx, from which we now introduce the upper and the lower bound to be 1 and 3. From here now, you integrate this one as 3x cubed over 3 minus 2x squared over 2 plus x. You know the usual method of integration. You introduce 1 and 3, which happens to be the upper and the lower limit of this particular integral. From here, we have this one to take care of this one to take care of this. So I now have x cubed minus x squared plus x from 1 to 3. I will put the value of x equal to 3 and put the value of x equal to 1. What I will just have to do is to subtract the value of x equal to 1 from that of 3. This one will give us 3 cubed minus 3 squared plus 3 minus 1 cubed minus 1 squared plus 1. So here you have this one as 27 minus 9. 27 minus 9 plus 3 minus 1 minus 1 plus 1. This one will take care of this. 27 plus 3 is 30. 30 minus 9 is 21. 21 minus 1 is equal to 20. The correct option to this particular question is option D, which is 20. We proceed to the next question, and that's question number 35. The angle between the positive horizontal x-axis and a given line is 135 degrees. You are required to find the equation of the line if it passes through the point 2, 3. Here, you have a line. You do not know whether the line slopes upward or downward. As it is here, our slope is tan theta, which is equal to tan 135 degrees. And tan 135 degrees is equal to minus 1. This implies that this particular line will definitely slope downward. And as such, we can sketch the line as this. Whereas this place is 135 degrees, and the gradient of this line is minus 1. The equation that describes this line can be proposed to be y equal to mx plus c. The gradient is already minus 1, which is tan theta. We have y equal to minus x plus c. Since this line actually takes a point which is 2, 3, it implies that x is equal to 3 and y is equal to 2. The essence of introducing this point is to find the value of the constant c. And the value of the constant c in this case is equal to 5. Therefore, the equation of the line is y equal to minus x plus 5, or y plus x equal to 5, or y plus x minus 5 equal to 0. So according to this, we can pick option C, which is one of those proposed equations. We move to the next one. The next question is that we should find the slope of the curve y equal to 2x squared at the point 1, 0. At the point 1, 0, we differentiate the function dy, the x equal to 4x. And since we want to find the value, the numerical value of the curve at this point, what we do is we set x equal to 1. Therefore, the slope will be 4 into 1, which is equal to 4. The slope of the curve y equal to 2x squared at 1, 0 is 4. All right. Question number 37. You are required to find the gradient of the curve. And the curve is y equal to 2 root x minus 1 over x at the point x equal to 1. Just like the previous question, what we just have to do here is to differentiate this particular given equation. And you are differentiating with respect to s. Therefore, we put our dy dx equal to d dx of 2 root x minus x raised to power minus 1. Remember, we want to evaluate this particular function, its derivative at x equal to 1. So differentiating this one, we are going to rewrite it as d dx of 2 x raised to power 1 over 2 minus x raised to power minus 1. If we differentiate this one, it's going to give us 2. This particular 1 over 2 will come down. it becomes dot 1 over 2. Then you subtract 1 from this one. If 1 is taken away from 1 over 2, the result is going to be minus half. Then we differentiate this one in a similar way. This one will come down. It will change to plus. Then we subtract 1 from the existing power. It becomes minus 2. This will take care of this. And we now have this one to be written in a fraction form as 1 over x raised to power 1 over 2, which is 1 over root x, plus 1 over x squared. Substituting x equal to 1, you will understand that here we're going to have 1 plus 1. Therefore, the answer to this question is 2, which is option C. Looking at the next question, which is question number 38. This question has nothing to do with differentiation because it requires obtaining the distance between 2 points and find the value of an unknown variable as given in the points. Remember that distance between 2 points given as d is indicated as change in x squared plus change in y squared. But according to this question, we have 2 points. The first point is x, 3, and the second point is minus x, 2. Here we have x1, we have y1. We have x2, we have y2. The values of y varies. The value of x in this example actually varies. Now, we recall that our d is given as x2 minus x1 all squared plus y2 minus y1 all squared. From here, our x2 is minus x, and our x1 is x. Our y2 is 2, and our y1 is 3. We substitute respectively by this assignment: x1, y1, x2, y2. So we substitute the respective values of x2, x1, y2, y1. So since the distance between the points is given to be 5, it is good to introduce 5 as the distance, which is equal to square root of x2. Our x2 is minus x, and our x1 is x. Minus x is equal to minus 2x. Minus 2x all square will give us 4x squared. Plus y2 minus y1. This y2 minus y1 is 2 minus 3. 2 minus 3 is equal to minus 1. Minus 1 square will give us 1. We take the square root of both sides. This one becomes 25 equal to 4x squared plus 1. This place we have 24 equal to 4x squared. The 24 emerge because if this one is taken to this way, it is going to be 25 minus 1. 25 minus 1 is 24, and we divide through by 4. And we now have this one as 6 equal to x squared. Therefore, x is equal to plus or minus square root of 6, in which the possible option could be x equal to minus square root of 6, and x can also be plus square root of 6. But since there is no minus square root of 6 in the option, we proceed to pick plus square root of 6 as the correct option, and that is option C. We move on to the next one. Question number 39. This question number 39 is a question on coordinate geometry. But you will see that this one is coming in a different form. And what is the requirement? The requirement is to find the midpoint of the segment of a line whose equation is given as y equal to 4x plus 3, which lies between x-axis and the y-axis. The first thing you must understand is that y equal to 4x plus 3 is a line. And we are going to quickly sketch this line so that we can find the midpoint. The midpoint is as well a coordinate. Therefore, via the intercept method, if to obtain y-intercept, for y-intercepts, we put x equal to 0, then we obtain the value of y. For y-intercept, the value of x equal to 0, then if x is equal to 0 here, it becomes y is equal to 3. Y is equal to 3. Because y will be equal to 4 into 0 plus 3. And as such, you have x equal to 0, y is equal to 3. The second one is for x-intercept. For x-intercept, the corresponding value of y is equal to 0. Then we proceed to obtain the value of x. If in the equation we put y equal to 0, we have it as 0 equal to 4x plus 3, and we have minus 3 equal to 4x. And as such, x is equal to minus 3 over 4. Therefore, we want to consider 2 points. The point will now be 0, 3, and another point is going to be minus 3 over 4, 0. This thing will definitely form a line. As a matter of fact, we might not even need to sketch the line any longer. What we just have to do here is to find the midpoint of these 2 points, because the equation has generated the 2 points. We have this one as 0 plus minus 3 over 4, everything over 2, then 3 plus 0 over 2. In this case, this is minus 3 over 4 divided by 2, 3 over 2. This one will give us minus 3 over 4 times 1 over 2, 3 over 2. This is minus 3 over 8, 3 over 2. Therefore, the midpoint of this line segment is minus 3 over 8, 3 over 2. And if you check the option, you will see that the correct option here is C, because it is minus 3 over 8 and 3 over 2. Question number 40. We are required to find the equation of the curve which passes through the point 2, 5 and whose gradient at any point is given by 6x minus 5. The gradient of a curve is given as dx dy. And according to this question, it is 6x minus 5. So you want to find the equation of the curve whose gradient is this. Remember, this particular curve actually passed through a point, and the point is 2, 5. What I expected to do here is to integrate. You have the y equal to 6x minus 5 dx. We integrate. Integral of the y equal to 6x minus 5 dx. Therefore, this one will give us y equal to 6x squared over 2 minus 5x plus c. This one will give us y equal to 3x squared minus 5x plus c. We substitute, we put x equal to 2 and y equal to 5. Since it passes through the point, y equal to 5, 3 into 2 square minus 5 into 2 plus c. This one will give us 5 equal to 12 minus 10 and plus c, of which we now later have 5 equal to 2 plus c. 5 minus 2 equal to c. Then we have 3 equal to c. Therefore, the equation which the curve will now be equal to y equal to 3x squared minus 5x plus 3. So this one, the correct option is D. Question number 41 is still on coordinate geometry. And here we have two different equations. And we are asked to find the value of k if the two lines are perpendicular to each other. The first line is 3y equal to 4x minus 1, and the second line is ky equal to x plus 3. So from each equation, we are going to make y the subject of the formula. From equation 1, I have y equal to 4 over 3 x minus 1 over 3. From equation 2, I have y equal to 1 over kx plus 3 over k. Since the two lines are perpendicular, the gradient of the first is 4 over 3. The gradient of the second is 1 over 4. So the product of the gradient must be equal to minus 1 since they are perpendicular. 4 over 3 times 1 over k is equal to minus 1. From here we have 4 equal to minus 3k. And we now have k is equal to 4 over minus 3. So the correct option here is A, which is minus 4 over 3, as you can